New in HyperLynx 9.2 is the ability to select multiple nets for simulation and export. If I go in here and select all my DDR2 nets, I can grab one data signal, that first data signal, and the field solver will start kicking off here. And then I can do a shift click and select all the signals in that first data group. So the first 8 data signals are selected, and if I want, I can also go down here and select, using control click, the associated strobes for that data group. Then I can zoom in and you can see that all those nets are now selected and active. And coupling is also active. So coupling gets controlled by the coupling thresholds. So however these are set is going to determine which signals have aggressors and how many aggressors. So if we look at this signal here where we have a long parallel run and look at the field solver output there, you can see that for that long parallel run it actually has 2 aggressors, and the coupling is active between those signals. And then if we wanted to turn on trace coupling, it would also include any other signals that were coupled into that group that we've selected. But by default, just the coupling within the group is enabled. And if I want to look at what models are assigned and what stimuli, I can use the new Manage Assigned Model spreadsheet here. And it has quite a bit of data, so it's hard to fit it all on my small resolution video here, but you can see that I can go in here and set the direction for a number of buffers. If I wanted to select a whole group at once, I could do that. So I'm going to make the controller the output and the memory the input. And then I have a number of stimuli assigned as well. So all the data signals have a PRBS assigned, and the strobe signals have an oscillating stimulus. And I've also offset the strobe signals to mimic the strobe actually clocking in the data, so you can see how the edge of the strobe is lining up with the data bits. And then I've also set that one signal that had a lot of coupling to stuck low, so I could see the crosstalk on that signal. So if I close that out, then I can run my simulation. So I'm going to set it up to use that per net per pin stimulus, and then move it onto the screen here and start my simulation. And you'll be able to see all of the data signals and the strobe signal all together in one waveform. And if we want, we can zoom in and you can see where, based on the thresholds, these data signals are going to get clocked in. We can also see our crosstalk levels. So here it looks like we have about 370 millivolts of crosstalk on that stuck low signal. So that may be something that I want to analyze and try and remedy in LineSim. So let's close that out and let's export these signals to LineSim. And you can see in LineSim I end up with a very large schematic with all those signals in there. So if we were to zoom in a little bit further here, we could see that I have all these signals with all the coupling between them, and if I wanted to look at that one section, that long section where I had lots of coupling, I could do that. And there's that section again. So if I wanted to, I could go in and edit that section to see if I could reduce that crosstalk issue. So if I go in and resimulate here in LineSim, set that per net per pin stimulus, I'll get the same results that I got in BoardSim. And if I close that, go in and edit that transmission line and increase that spacing. So right now it's very tight. It's only 4 mils between the traces. If I increase that to 16 mils, go back and resimulate, I should be able to see a significant reduction in the crosstalk. And so let's zoom in on that crosstalk waveform. And I start off at around 370 millivolts, and now we are down at 190. So basically we divided the crosstalk in half by spacing those traces out a reasonable amount. Now, in addition to exporting the line sim, you can also export to an S-parameter model to look at the S-parameter data, or use another simulator if you want. And if we look at that exported S-parameter in the Touchstone viewer, if you remember, let's see, port 7 was that data 3 bit that had all the crosstalk on it. There's its return loss, and there's its insertion loss in blue, and then the crosstalk terms to those other nets are going to be those other ports here. So you can see the S parameter has all the proper associated coupling from our selected group. And that is the multi-net selection feature in HyperLynx 9.2.